Alright, so welcome back to another video on Node, specifically looking at sockets. So I'm going to make a quick recap on that because this is something that is an exciting topic to me and one of the fundamentals of the internet. So let's imagine that we're going to build a chat application with all the things that we already know, right? So using the HTTP protocol to do that, if we want to send a message, we can use a post request. And if we want to read all the message, we make a get request. But there's a question: is that how do we know when to fetch data from the client perspective, right? Data that is outside of our control, data that we didn't create, that might be in their own life cycle. For example, in games, trading, or self-driving car. Okay, and sometimes we deal with this kind of situation, like when do we fetch the data from the client perspective using a concept called polling, which the clients perform a get request so often in a certain period of time, and when that time has passed, and it send a new get request in a loop essentially. So with this approach, which is quite effective, there is some trade-off because once I look at this pseudocode, when you use the set interval JavaScript features, alright, that under the hood would use the web browser API or the web API from the browser to perform this. Okay, so in any case, so set interval, it will send based on the pull rate, which we set as 500 milliseconds, read the data, right? But the question is there a right amount of time? Uh, doesn't depend the data change, or doesn't it depend doesn't it depend how often is the data change on the backend? So even though with this approach, the best we can do is just good enough. So for a chat application, that might be okay, but for the real stuff like trading, games, or self-driving car might not be the case. So in any case, for our chat app, this might work. And if we want to set that to 500 milliseconds, uh, there is another issue because not only we're adding is 500 milliseconds to all updates, but also we're making is 2 requests per second and 120 per minute. And this is just for one single user. Or do you need a very powerful server for a different approach? So sockets come to the rescue, and sockets, from their plain definition from Merriam-Webster, this UK online dictionary, they are opening or a hollow that form a holder for something. For example, the electric bulb sockets or your eye sockets. So in the context of the data, so this data socket is an opening in a computer system. A computer is a programmable machine that can perform logic and arithmetic operations that when you talk about system, computer system, this machine is made of hardware, software, the most common software is the OS, and it is peripheral. Any device that you need to interact with the machine. So you have is a keyboard, mouse, speaker, monitor. In the case of laptop, it comes everything built in here. So this opening in a computer system in which you can connect to send and receive message. So it's a holder for this type of connections in a network computer. So this network computer, which is a series of computers providing and sharing resource or providing by network nodes. We can think of them as a person if we think for demo purpose, okay? If we make that analogy to if a computer is a person, which after all, it exchanges music, literature, knowledge, fluid, insults, you name it, right? So this person, which can be seen as a computer, which share resource, is a series of computers, all right? The computer network is a series of computers that these interconnected computers can form something called the autonomous system. Much like when we have, for example, on a state or a province or oblast or whatever geopolitical organization your country may, okay? So you are connected or you exchange with other type of people in a particular area. And all of those people that belong to that geographical location, they are called, for example, Venezuelan, Colombians, Argentinians, the United States people, or you name it, right? So now, in the context of computer systems, they are called autonomous systems that operate under a single admin domain. In other words, Google, Facebook, Cloudflare, and so on, right? So each one of those names have an interconnected series of computers that they provide certain capabilities. So the reason of why I'm explaining this is specifically the autonomous system concept is because when I look at the computer network, right, which is the series of computers that are sharing resource located on similar as person located in a geographical location. So for example, on the Latin or UK or US or Europe, Africa, Asia, Middle East, Australia, and that this sharing of this resource locating on or provided by network nodes, you might have in these network nodes redistribution endpoints such as BGP. After all, BGP is an exchange uh, exchange routing protocol between these two autonomous systems, okay, or communicational device or communicational endpoints. Any is an IP address or is an address that are allowed to identify any communication device, uh, such as applications, server, desktop, uh, firewall, router, switch, you name it. Okay, and this concept is something important to understand and be able to mention that because now when I look at the IP socket, which is the basic building block for the internet, this opening in the computer systems, right? So IP socket, on top of that, you have these something called datagram sockets, where low latency is the most important factors, and the connection base such as TCP, were are reliable, meaning that before to send or receive a message, you need to connect, and you can know if a message that you send it was received or not. So on top of the TCP socket, we have is the HTTP protocol. All right, this is a half duplex communication, and the web socket, which is a JavaScript features that enable this two-way communication of data between the user browser and the client server. So that's very awesome. That's powerful. That's incredibly useful and beauty, wonderful to look at it because it's not the server. Sorry, it's now the server who is responsible to keep the client up to date. So the client doesn't need to guess when the server asks for data. So the client doesn't need to figure out when to ask data to the server. So then I look at the implementation of that, right? So similar as the HTTP protocol, which has similar implement or several implementations such as Axios or NoFetch, WebSocket has that as well. So you have is the WS, Node.js, this is the WS node socket, like this. Exactly. So like WS, node socket web library. Okay. That the only trade-off with this is that only works on the server, not in the browser. But they provide you other, or they provide you a similar wrapper and less popular library to use on the client side, right? We also have another implementation uh, which it comes with full battery includes and is much more powerful than the WS because with WS you can is create the connection or the model use the model from the server and on the browser uses the web socket browser, right? You can use this the WebSocket API, okay, which here it has there is no WebSocket API. The WebSocket API. What about example? Writing WebSocket clients exactly. So here you go. Right. We're here. So, for example, the WebSocket here. So the thing is that with WebSocket, you can connect to a WebSocket, right? And you're gonna have this mismatch of this interface mismatch between the browser and the server because after all, they use is the event emitter class from that like on to listen to an event or send. Okay, so you have this interface mismatch between the client and the server. Okay, and also if the client doesn't support the WebSocket, you cannot use it. So now socket.io here provide a very convenient way to establish real-time communications, bidirectional, event-based driven that support fallbacks and works in any uh, environment. So the way it works is by having a client and a yeah by having a client and a server library that even though both of them has different responsibility, they use the same interface. So for example, the client and the server. So you don't have to worry about juggling two different APIs with different set of functionality. You can focus on building your app code, and this allows to save brain power to creating new features as opposed to hunting bugs, which after all you have to do that. But if you can reduce that at least for 10 or 20%, we can save a lot of time. And also we don't have to worry about compatibilities, which the way how this works and is very very important when building large scale production applications is that Socket.io, when we use that on the client, will attempt to establish a WebSocket connection. If your browser is those, or if your browser are those less than 1-3% or less, it doesn't support that, it will stick to form poorly. And this way, we can ensure that your application works in all devices. Your application will work on all devices. A very important in corporate environment. So now looking at the implementation details, right? And see that the client, after all, is going to talk to the same server. So this is the responsibility. Whereas the server has different responsibility because first it needs to keep the client up to date. All the connected client will keep he will keep up to date all the connected clients, track multiple clients. He can send message individually to a group of people or to a group of connected clients or broadcast message to all connected clients. So the reason of the Socket.io success is the excellent high-level API that provide for both the client and the server. And both are based on the event emitter API from Node.js. So if we want to send a message, we can use this socket.emit. Okay, and if we want to broadcast to all connected clients, we can use the IO emit. So if we compare that, for example, the broadcasting to all clients, right? Uh, so if we compare the code needed to broadcast to all clients or to broadcast a message with Socket.io and the WebSocket implementation, so we looked at it only takes just one line of code, and this is powerful. This is one of the reasons why Socket.io is is tremendously uh, useful, and it is huge success because it provides this high level API for you that works. It provides this high level APIs for both the client and the server. And it is based on the event emitter API. So then I look at how can we use this to implement a multiplayer pong game. So if you're not familiar with Pong, so it was one of the first video game released in 1972. We're talking about 3 years later after ARPANET. Okay. So yeah, we make some code review here on this code that they give us, and to understand a very important concept on game, which is called game loop. So every game has a game loop. So from basic games like Tetris or Pong to modern webs like Fortnite or and Minecraft. So here I'm looking is the multiplayer Pong sequence, right? And this is we're going to extract a lot of the logic to prevent a player to cheat, okay? And that is, for example, to calculate is the ball and other non-random logic. And if we take all of this non-random logic to to prevent the user cheat or a player cheat to the user, well, what we have here is yeah, what we have here is that the server will deal with a lot of responsibility. For example, yeah, the servers will handle a lot of responsibility here because after I make this code review, I saw that in order to prevent that user cheat, we take some of the non-random logic to the client, to the server, uh, and see that it will put some load, unnecessary load on the server. So if we want to make our server thin as much as possible, we use a UML to lay out what will be the responsibility that this server will have, okay, and to make that as thin as possible. So looking here at how we can set up a socket.io server from scratch using is the HTTP model to create a server, and this is for versatility reasons. Okay, so for example, if we want to use HTTPS or attach our socket to an existing Express app, we can do that quickly. Yeah, that's right. And so now once I do that, right? So now that I set it, now that I set the socket.io server, and now look at how can we set up the socket.io client using the CDN for that. And because by default, socket.io will start to attend, uh, yeah, by default, socket.io attend, or by default, socket.io send an HTTP, establish the HTTP request, and then upgrade the connection to a WebSocket, and it do that automatically for us. So that's another convenient, that's another benefit of using Socket.io. Okay, and then how can we listen for events on the server side? And how can we broadcast this on the server side? Pretty much something that I'm quite familiar with. So there is nothing new about that. Perhaps just to put some server code here for that. Okay, perhaps putting some server code here or here without doing this. This is how do we listen events on the server for that server.js. Okay, uh, and because to create this multiplayer Pong game, we're going to set one player as the referee who will be a single source of truth, or uh, the player that will in which we're going to trust, okay, to take, for example, to uh, take notes or take points notes. All right. So here we reach at handling events in the Pong client. Okay, because what we're gonna do is to broadcast an event, a particular event, to all the connected clients. In this case, we only have two clients. After all, we're setting this multiplayer Pong game with just two players. Okay. Cool. Cool. By the way. Cool. What? Oh, come on, man. Okay. Right on now. Maybe there. That's right. And here we are. Let's go. And here we are. So detailed implementation to me is something that might not be necessary, because in my case particularly, I am well aware and quite familiar on how to do that, you know. So I can skip that. But if you're not, you should look at the code and understand that.
Game event. Now, what do we need to do on the client side to start the game? We're going to add a handler below our connect handler for our start game event. And our start game event has a parameter, which is the ID of the referee. So we're going to take in the referee ID. And we can log this for testing purposes. The referee is the referee ID. But now we need to keep track of whether this player is the referee or not, so that we know whether we are the ones to keep track of the score and keeping track of the ball position. So we're going to add a variable at the top here and say that we default to is referee equals false, referee with just two E's here. And if a certain condition is met, then we'll set is referee to true. We know that we're the referee when our socket ID for our client, which we've initialized here at the very top, we know we're the referee when this socket ID matches the one we're getting back from the server. And now that we know who the referee is, we can do something here to start the game. But our start game function over here that runs on load does a little more than what we need here. It handles both the three things here that we need on load, and then all of these actions here, which need to be executed when the game actually begins. Let's separate the game loading code from the game starting code. So we'll say that this is the load game function.
Mm-hmm. So this is the load game function.
And call load game on load.
On load. Called load game. Load game.
And then we'll create another function here below load game that is start game.
Okay, so we're going to create another function here. That is start game. Like that.
And it's in this start game function that we will begin the game loop and start listening and responding to user input. And let's just make sure that our comments here are relatively accurate. And we can call.
Just load in. And we can go if the start
start game when we've received the signal from the server. Now, if we go to the start game function, we'll notice we have this paddle index variable.
So when we receive the signal from the server, we can start the game,
which is hard-coded at 0. This represents the paddle that the current player is controlling. In single player, it made sense for it to always be 0, which meant that the player was always controlling the paddle at the bottom of the screen, which we can see in our render canvas function. The paddle with index 0 is the bottom paddle. But with multiplayer Pong, one player will be controlling the bottom paddle, and the other one will be controlling the top paddle. So in our start game function, we'll determine who controls which paddle based on which player is the referee. Now we could decide this randomly or using any logic that we want.
Okay, so we can do this randomly or any logic that we want.
But in our case, let's just say that the paddle index for the referee will be 0. So the referee controls the paddle at the bottom of the screen, and the non-referee player will control the paddle index at 1, at the top.
At the top, that's right. So we can add some logic here. So who controls which paddle at 0. So if it's a referee control at the bottom, all right, and if not a referee, it will control is the top. So no.
Top of the screen. Now we've set up our game and we're ready to start playing. Let's test our code and make sure that the game is starting correctly and the referee is being assigned. So we'll do npm start, and now we can start 2 browsers side by side and see if both get the signal to start the game.
And then start, and we can start here 2 browsers here. Where is the local host 3000?
From.
Oh, that's right. That's right. Because here, when it is to open, is this. Explorer, and that's exactly what we need to do. Is open with Chrome. That's right.
The server. The game is starting correctly, and the referee is
And we got it. That's right. And we run this. I'm not able to connect for the reason. Unexpected token. That's right. Here we go. Load canvas. And start game. Okay. Unexpected token. Which position? Which line? Can you tell me? Okay, 162 is this. Because an expect token is like this. Oh. So now, that's right. So here we are, waiting for a point. And there you go. Right. You get one here, and the other is here. Okay, you have to close here the terminal and open this file here. Okay. Mm-hmm. Perhaps because you're assuming that this is from the same source. Okay.
Is being assigned. So we'll do npm start, and now we can start two browsers side by side and see if both get the signal to start the game from the server. And now we have our game starting.
Okay, open a new browser here. You browse the tab. And navigate to that. And no, for some reason you're not.
And now we can start two browsers, the paddle at the bottom of the screen, and the now we could decide this non-referee, set up our game, and we're ready to start playing. Multiplayer Pong. One.
Hmm. Yeah, well, this you have
Let's separate the game loading code from the game's for our client, which we've initialized here. Matches does a little more. We're getting back from the.
Perhaps the way how do we assign the logic here? Exactly. Perhaps the way we assign this logic is that we're never getting is that. Reload here. Reload here. Hmm. Interesting. On the server side, we're emitting start game. Did we add that handler? Yes. Referee is. Referee is. Connected as. But it seems that socket like this can emit this to the socket. Then you're gonna emit this event. But for some reason here, when the socket is ready, okay, player ready, and ready player count. So let's go to run our server here. Okay, but for some reason it's not emitting the signal. If real player count is equal to 1 and 2, hmm, for some reason it's not sending the signal. And here, connected as this So you're not listening to this event to the start game. Socket.onConnect, we have this, but socket.onStart is because the logic here is never reached. So if the ready player count is equal to 2, you're supposed to emit this event, and for some reason it's not doing that. Ready player count 0 plus plus, alright? So once you listen to the ready event, you're going to add this and add another one. Why you didn't trigger that? What about now? I love it. It's never getting here. Okay. Because here, even though you're emitting here, you expect something. Or not. We're not. Because emitting is the ready event. So now, still doesn't work. Okay. You should emit the ready event. On load gain is here. So it listen to this, but it never print here anything. Socket that on. Ready. Socket gonna emit the ready event. Okay. Possible. Very, very possible here. But you can print the idea of it. But for some reason you're not reading this. This ready event. Socket gonna meet ready event. Okay. Alright. Exactly, so why not? Exactly. What the hell? Socket around net. So the client side is printing this, but it's like no send. It's like socket.emit. 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 Okay, here we are. Okay, here we are. File index is referring 0. There's a reason we're emitting is this event on login, alright? And for some reason, login, perhaps here we are not triggering is this login. Yeah, we are. And that's why the auto connection. The auto reconnection here, that's right. So that I'm gonna, but even the ready player, but here we are not listening is this. This is something puzzling to me. It's like why you not able to read this? Shopping that on ready. Oh, that's right, that's right. Because here, even though the, yeah, but still, player ready. Exactly. Now his triggering is the variable. Player ready. Now his triggering is this. So now he's listening to the event. Okay. So now he's listening to the event. That's right. And for some reason it says something like this. Must be in the logic. Is referee the referee ID on start game. Assignment to constant variable. Okay, but this is because you're in strict mode here. That's right. We need to assign that as a variable, not as a count. Right. So okay. So even the browser is helping here us for now. Of course, this won't trigger the game. If you do here this and this again, now you have this. Of course, the thing is that there is a disconnection between one browser and the other. The disconnection is from the ball movement and the score as well. But we were able to connect now to client here. But now we were able to connect here to client here, right? Here we're handling is the bottom, all right, which is the referee, and this is handling is the top arrow. So that was cool. That was great. Okay, that was cool. That was great. Here we can say is git status here, git everything, git commit minus n to um, uh, set referee player like that. So git push origin to the main branch. There you got it. Okay, cool, cool.
The server. And let's just code and make sure with my player input at the bottom here working. And if I click on the window on the right, I'm now moving the paddle at the top. But you can see that there's been a disconnect between the
So now look at this. handling event in the client. And for that, we can set things like this. You know, so the way how do you handle events, the way how do you listen events on the pong, the way how do you listen events on the server is by using is the IO instance and the on interface, and much like the same from the client, right? So you have this same interface. So the only thing here is that we have a mismatch. Okay. Oh my God, no. The only thing here is that we have a mismatch. The only thing here is that we have a mismatch between. We have a mismatch.
Player on the left and the player on the right. The scores don't match up, and the position of the paddle.
We have a mismatch between. Yeah, we have a mismatch between the score, the paddle, and the ball.
On the bottom and on the top here doesn't match up, and neither does the position of the ball. So we'll need to synchronize the data between both clients. But for now, let's make sure that the referee is being assigned correctly. So we can see that on the left we have this player ID, and on the right we have this player ID, where the left one is the referee, and the one on the right is the non-referee player. On the server side, we can see that we got two users who connected, and they both sent player-ready events. Amazing! We're ready to implement the multiplayer game logic and keep the clients in sync. I'll see you in the next one. Welcome back. Now that our two clients have connected and started our game, the last and most important piece of our socket project will be passing the game data back and forth between the two clients by sending messages through our server and keeping the clients in sync. This way, the same game is being played by both players with the same game state. If you've ever played any sports, for example, you'll know that playing on the same field with the same ball is very important to having a functional game and having fun. Or if you've ever played a board game, playing on the same game board with the same pieces is equally important, at least if you really want that multiplayer experience. So let's get into it and make our Pong game truly multiplayer. The two main pieces of data that we need to synchronize are both players' paddle positions, whenever the paddle moves, and the ball's position on the game screen, which will also involve synchronization between the two clients. Let's look at the paddle position first. Each player's paddle position is determined only by the x position, or the x coordinate of their paddle, which we keep track of in this paddle x array over here. Index 0 for the player at the bottom, and index 1 for the player at the top. So this is the piece of data that we'll need to pass from one client to the other through our server. And we're going to pass this paddle x variable, we're going to emit it whenever the paddle position changes, which is going to be whenever we have a mouse move event in our browser. So right here in this event listener, right below where we're updating the paddle x at our player index for the current player, we're going to do a socket.emit and emit our paddle move event. That's just what we're calling our event. And we'll pass an object as the payload here with a single property, which is going to be the x position of the paddle as it's moved. And that's going to equal the paddle x at the current player's paddle index. Exactly the variable that we just updated here. So we're sending the current player's paddle position as it's being moved to the server, so that the server can then re-emit that position to the opponent's browser. So the two paddles are in sync. Now on the server side, we're going to add a listener with our socket.on function, again listening for our paddle move event, where we're sent our paddle data object, which contains the X position of the paddle. And remember, we're going to need to keep both players' positions in sync, which means when we receive these updates, we'll need to broadcast this data back to the other clients, or in our Pong game, the one client, which is the opponent player. This means we're going to use a different broadcast this time. If we go back to our emit cheat sheet over here, instead of...
So we're going to use the opponent for that.
Sending our event to all connected clients, like we did when we were starting.
We're going to send is for the client. So we're going to send to all the clients, in our case, except the sender.
In the game, this time we'll use this socket.broadcast.emit function, which will send the event to all clients except for the one that originally sent it. So we're essentially forwarding the data that we receive, or in our Pong game, the paddle data. We're forwarding this data that we receive to all the clients except for the one that originally emitted that paddle move event, so that the sender doesn't needlessly get updates on their own position, which they're already aware of. So we're going to do socket.broadcast.emit and passing in the same type of event, the paddle move event, with the same data. Only this time, passing it to all the other clients except for the sender. Now on the client side, we're going to need to handle updates on our opponent's paddle position. So we're going to need to listen for using socket.on, once again, a socket.on paddle move event. And this is where we're going to need to update the game state in this client to reflect the game state on our opponent's client. Specifically updating our paddle X array, and even more specifically, at the index for our opponent. So we're going to have a variable, let's say opponent paddle index, which we're going to assign to the X position from our paddle data over here. And we'll update this variable here. It's the data, not the event. And we're going to take the X position. But what are we going to set this opponent paddle index to? We know our paddle index, which is in this paddle index variable here. But if you remember, the opponent's paddle index would be 1 if our paddle index is 0, and it would be 0 if our paddle index is 1. So one way we can accomplish this reversal of paddle indexes from ours to our opponents is by subtracting the paddle index from 1. Which again means if our paddle index is 1, 1 minus 1 is 0. And if our paddle index is 0, 1 minus 0 is 1. So we'll always toggle a 1 into a 0 and a 0 into a 1. Now if we start our socket server back up, we can see that our two clients over here, our first one over here and our second one on the right, have automatically reconnected, but the game hasn't started because they haven't sent that ready event. Remember, the ready event is only sent the first time that our game loads on this load game function. We only emit our ready event the first time. With the way our code is written right now, the quickest way to send that ready event is to refresh both clients. And check it out. The paddle position is reflected on both clients. I am currently moving the client on the right, and it's being kept in sync with the client on the left. Same thing in reverse. But there's something weird happening with the ball position. We've gone slightly out of sync between both clients, and the game state has become completely different, which we can see reflected in the scores. Let's find out how to take that final step and keep the ball in sync in the next video. I'll see you then.
Alright, and for that, that'll be all for this video. Take care. Bye-bye.